A very happy good evening to everyone of you. Guys, today we are going to see the differential calculus. That was one of the important subjects, it means important chapter in the entire mathematics. So without wasting time, let us get started. So welcome to my channel. My name is Surengoku and let us get started. So differential equations and differential calculus. Okay. So what is a differential equation? So differential equation means why we need the differential equation. Because while we are just integrating this, while we are just differentiating, we can exactly know whether the function is, it means whether the value has been increasing or whether the value has been decreasing. Okay. So general, it means general basic is dx upon dt. Okay, that's it, basic. So you can see it's it's an equation that contains both function of x of t and its derivative. Okay, dx upon dt equal to x square of t, and equation containing derivative form. Okay, that's it. See guys, while the video is going on, I'll just explain each and everything to you. Okay, so until then don't worry. So this is the first order. So first order means dx upon dt. Second order means you can see the square is been there. So d square by dx square plus 2 dy of dx. Okay, plus 4y. You can see it's an equation that contains function of y of x and both first and second derivative. Okay, I think so you can understand. So differential, so this one I'll just explain later, but I think so you are getting the point. Okay, so see why the differentiation is so much important. Means without differentiation and without integration in the world we cannot, it means none of the thing will exist. Okay, that's why the differentiation and integration is so much important thing. Okay, so this one I'll just explain. So okay, so you can see differentiation means derivative means decrease the power of variable. Okay, and vanish here. While we are just differentiating, the constant will get vanished, but while we are just integrating, the constant will come. Okay, and also the increasing power. Okay, so you can see differential equation is a form in, it means a dependent variable and in terms of independent variable without any constant. Okay, so guys, please means just listen, and if you don't understand, the video will go and you will get a clear cut understanding. Okay, so because while I just heard also little bit of quite, it means tougher thing was made for me, but as the video goes I just understood. Okay, so differential equation, so you can see ordinary differentiation equal to y equal to function of s. It means you can see it's, how to say y is function of x. Okay, you can see y is entirely dependent on x. Okay, I think so. So if dx upon dx upon dt is, I think so it's just a normal thing. So dy upon dx is generally constant. So partial differentiation y is x comma. So you can see the entire u is been divided on x and y. Okay, so it's been dependent on the both of the two. Okay, it means u depends on x and as well as the y. Okay, so differentiation of u of x is dou u upon dou x, and differentiation of u of y is dou u upon dou y. Okay, I think so you can understand. So differentiation of x power n is n of x n minus 1. Okay, so it's just a formula, guys. I think so you can understand. So next one, differentiation of ln x is 1 by f x. Okay, I think so you can understand. So you can see equation contains one dependent variable or one or more independent variable, and the derivative of one dependent variable with respect to one or more independent variable is called as differential equation. Okay, I think so you still haven't understood. So you can see the equation contains one dependent variable. So you can see y is entirely dependent on x. Is x dependent on y? No, definitely it is not. Okay, this y is dependent variable and this x is independent variable. Okay, so you can see u is entirely dependent on y as well as x. Whether y and x is dependent on u? No. So this side is okay, but this side definitely not possible. Okay, equation contains one dependent variable or one or more independent variable. Okay, you can see one independent variable, so one dependent variable, or you can see one or two more independent variable. The derivative of one dependent variable with respect to, it means derivative of one dependent variable with respect to one or more independent variable, such a equation is called differential equation. Okay, so do not get confused. As the video proceeds, I'll just explain each and everything. Okay, so this is basically the differential equation contains only ordinary derivatives. You can see this are ordinary derivatives. Okay, so you can see y and dx. Okay, where is the thing? So you can see here y is entirely dependent on x. Okay, I think so you are able to understand. So you just wait. Okay, so you can see ordinary differential equation. The differential equation contains only ordinary terms. So here no, it means no bigger thing, no other thing is been there. So you can see y and x. So generally y and x is been. So partial means you can see partial derivatives x and y with respect to u. So you can see the upper portion is dou u by dou x plus dou u by dou y equal to 0. So you can see u is dependent variable. U is dependent variable. Okay, x and y are independent variable. Okay, so I think so you can understand. So you can see order of differential equation. The order of highest order derivative occurring in the given differential equation is called order of differential equation. Okay, it means highest order. So you can see this one dy by dx. Suppose if d square y by dx is given, so order is 2. Okay, so here you can see d power 4 upon y of dx power 4 equal to 0. So you can see order is 4. The highest order derivative occurring in the given differential equation. That's it. Okay, if it's with degree means you can see this is square, so the square is called as it means degree. The highest integral power of highest order derivative occurring in the given differential equation which is free from radicals. Okay, free from radicals. Okay, so radicals I just told upon is called free from radicals and fraction. Okay, so generally it means this kind of things doesn't occur in while finding the degree. Okay, suppose if you can see here what is an order. So you can see here 3 and 4 is an order. So which one has the highest order? 4. So for 4 what is the degree? 10. Okay, that one will be okay. You should not take this 14. I think so got the point. So this one is you can see u is dependent variable in this question. U is dependent variable. Okay, x and y are independent variable. So you can see what is order. Order is 3. Here also 3. Okay, 3 is the thing. Okay, order is 3. So what is the degree? Degree is 20. Okay, I think so you can understand. Okay, so next thing they have asked this question, what is an order and degree? So make this 2 inside. So x plus dy by dx 3 and d square y by dx square plus d y by dx, this 2 go place it inside. Okay, 4. So you can see what is the thing. So order is 2 and degree is 4. Okay, you can see order this one, degree this one is order is 2 and degree is 4. Okay, I think so you are catching the point. Where is my pen? So another thing, whenever the formula is given x plus of y, suppose 1 x dash of y dash. Okay, if x plus y, the square is x square plus y square plus 2xy. Okay, if x plus y, the whole cube is being given means x cube plus y cube plus 3x square of y plus 3xy square. Okay, I think so you are getting the point. So next one, degree of differential variable. So how to find degree of differential equation? You can see it should not have fraction, so fraction should not be. Next one, radical should not be. Next one, transdutional function should not be. For example, e of x, tan x, cos x, sec x, like that should not be. Okay, so why? Because you can see if transdutional function means sin of x is x minus of x cube divided by 3 factorial plus x power 4 x power 5 divided by 5 factorial. You can see the degree continuously varies. Okay, that's why for this kind of equation we don't consider the sin x, tan x, these kind of things. Okay, I think so you can understand. So next one is degree may or may not be defined, but order is always defined. Okay, so degree may or may not, but order is always. So next one, linear differential equation. So a differential equation is said to be linear if the power and the degree, okay, if the power or degree of dependent variable, okay, must be 1. Okay, I think so you got the point. So just the power or the degree. Okay, please don't consider about my handwriting. The power or degree of the dependent derivative, okay, dependent derivative and dependent variable must be 1. Okay, for example, dou u bar dou x upon dou y, if it is in square, it is not linear. Okay, dou u by dou x 1. Suppose dou u by, so dou power 4, dou power 4. So degree, what is degree? Degree is 1. Order is 4. So it is linear equation. So degree must be 1. That's it. So and the product of dependent variable and its derivative should not occur. Okay. So it means dou u upon dou x and x. So like this it should not occur. So you can see u is completely dependent on x. So you can see here multiplication of dependent and independent should not occur. Okay, and the transdutional function should also not come. Okay, it means sine. So suppose if you use a dependent variable, so you use a total function of x comma y. Okay, you can see use a function of x comma y. Suppose if sine u, if it like this comes, it's not. Okay, we should not take the degree. It is not linear, it is non-linear function. Okay, I think so you are able to understand. So here you can see u is a function of x and u is a function of y. So it is, you can see this one. Okay, if it is a linear or non-linear, you can see degree is 1 and the degree is 1, degree is 1, and sine of u is not the log of u is not the, okay, sine x and sine is, okay, it's a linear equation. So what's this one? Here you can see y is dependent on x. Okay, here you can see e of x. Okay, it should not come, and you can see y power 4. So I think this is completely a non-linear function. So you can see y, you can see guys, here the transdutional function also should not come. So you can see where is that one? See, transdutional function is e of x and log x. This also should not come. Okay, so you can see here dy upon dx, and you can see here the dependent variable comes. So definitely it is non-linear, and y of e of x. So you can see it's a non. So you can see this. Oh, see, you can the entire thing y power 4. So y power 4 is dy upon dx power 4. Okay, so degree is 4. Here it's non-linear. Okay, I think so you're able to understand. So next one, here u is dependent x y. Okay, so you can see yes. See, we made a good mistake. Okay, so while we made a mistake, that will be continuously in our mind. Okay, what mistake I just made is, you can see I just told this one, the product of dependent variable and its derivative should not occur. Okay, what I just told, dou u upon dou x, here x should not be like that registered. But what is the main case scenario is, here dou u upon dou x, u should not be. Okay, you can see this is a u is dependent variable and its derivative means derivative is dou u upon dou x. Okay, this only should not be. So you can see here it's dou u upon dou x, and how the x will come. So the entire thing will be non-linear only, but you can see this is linear. Why? Because here the u should not be. Okay, that's it. So sorry for my mistake, but anyways, thank you. Okay. So next one you can see. So you can see y e of x. So like this kind of thing should not be. Okay, and you can see y dy upon dx. So this also should not be non-linear. Okay, and so you can see. So suppose you can see if y sin x can be, y of sin y should not be, or x of sin y should not be. Okay, it is non-linear. Okay, e of x u can be, and log of y should not be. Why? It is transdutional. Okay, so log x can be or log u can be. Okay, because they are both are independent. I think so you're able to understand. So we can just go to the next thing. It's about homogeneous equation. Homogeneous differential equation. So you can see if every term of differential equation, so homogeneous function, you can see what is homogeneous function. If every term of differential equation contains dependent variable. Okay, if every terms of differential equation contains dependent variable and its derivatives, contains dependent variable and its or its derivatives, such an equation is called as homogeneous equation. So okay, so every equation, okay, every okay, not a single thing. So you can see y is a dependent variable. Okay, here y e of x should not come. Wait, y e of x it can come. So y e of y should not come. Okay, y e of x can come, and do d square y by dx. Okay, this one. Okay, since the degree is 1, so this one, okay, linear will come. So e of, you can see e of y should not come, it's non-linear, okay. But 4 is you can see here there is no dependent variable, so it is non-homogeneous, okay. So next question they have just given like this, the dependent variable u and u of x, you can see this one. So you can see e of x of u, so you can see u is the dependent variable, it been contained, okay. E of x sin of u, okay, sin of u should not come, it is non-linear but homogeneous, okay. See, mostly the questions will be asked based upon this only. So here you can just see u is dependent, okay, let us write it down. U is dependent variable, x and y are independent variable. So you can see e of u should not be, okay, e of u is there means it is non-linear. Sin u also is non-linear, and here sin x is there. Sin x, where is the dependent variable, okay, where is dependent, so u of sin x can be, or dou u upon dou x of sin x can be, so it is non-homogeneous. Perfect. So this one, so so you can see dou square y by dou x square 1, okay. So this is independent variable, okay, independent variable can be, but you can see here it is independent variable, x is independent, but there is no y, it means dependent variable here, so definitely it is non-homogeneous, okay. And here, okay, du upon du, okay, definitely what is in order, order is 2, degree is 1, and it is homogeneous or non-homogeneous, it is non-homogeneous and linear equation. Perfect. Clap. So okay, I think so you understood. So solving ordinary differential equation, you can see types of solution. So generally solution, if the number of arbitrary constant in a solution is equal to order of differential equation such that solution is called as general solution. So just explain, okay, particular solution means general means general solution, particular means particular point and precise location like that. If a solution is obtained from a generalized equation, this one I'll just explain, okay. So no need to confuse. So next one you can see this one, suppose dy upon dx of equal to 5 means integration. We can see this is generalized equation, okay, cx plus of c1 is general solution. If y equal to 0, x equal to 1. So you can see c1 equal to minus of c, while you have been putting here you can see particular solution. So if what is the value of x, definitely will come, okay. So next it's been first order, okay, everything is been first order. First order means dy upon dx the whole square, because degree they haven't just given, okay, or maybe they would have, so okay, but first order means you can see order n equal to 1. So it means we are just seeing the 6 equations, okay. These 6 are most important, okay. One is variable separable method, second one is homogeneous method, third one is exact method, fourth one is non-exact method, fifth one is linear differential equation, sixth one is non-linear differential equation, okay. So I think so you can understand. So this one, okay, variable separable method, this variable, you can see variable separable method, separable means separate, that's it. So for example, if dy upon dx is there and y dot x square is there, so you can see dy y and dx x, okay, just make this y and x square of dx, okay. This is variable separable method, okay. We just separating, that's it, separating, and you are just calculating the entire equation. I hope so you understood. So we can just see the first equation. So dy upon dx is cos x plus y. Oh guys, see, you please don't confuse. So because while it's been x plus y is given, just make it as z, okay. Dy upon dx equal to cos of z, okay. So then x plus y is z, okay. Then convert this one, dy upon dx So you can see while we just differentiate this one, so y equal to z minus of x. So dy upon dx is, so dz upon d, which one will come? Dx will come, minus of 1. Okay. So suppose if you want means d by dx z minus of x. Okay. So is it different? Dz by dx minus of dx upon dx 1. Okay. Dz upon dx minus of 1. That's it. Just a basic calculation. So you can see this one, dz upon dx equal to minus 1 equal to cos of z. Okay. Make this one this side. So dz upon dx 1 plus of cos z. Okay. Dz upon 1 plus of cos z equal to dx. So now you can see z to z is z, x is z. Okay. Now we just convert in variables. Now we just do in the integration. This one will be quite difficult because in this one first problem itself, each and everything is been explained. Okay, that's the main problem in this problem. So okay, so it's been converting. That's it. Okay, you can see how much conversion is been occurring here. Okay, suppose dz upon which one, 1 plus of cos z equal to dx. So integration. So here this side will come definitely x. Okay. So how we can just convert this entire thing? So 1 plus of cos z. Okay. Wait, I'll just explain. So you can see what is the thing. Like this, if we just got the equation 1 plus of cos a equal to 2 cos square a by 2. Okay, just put it dz 2 cos square zz by 2. Okay, equal to integration of dx. So I think so you got the point. So cos square z by 2. Okay. Integration so you can see what is the thing, cos theta equal to 1 by sec theta. Okay, so here it's been given 1 by cos, so 1 by cos is sec. Okay, that's it. So it means 2, just make it over there, dz by cos square z by 2. Okay, so then definitely what will come, integration of dz integration of sec square z by 2 of dz. Okay, equal to integration of dx. So see how much thing is being complex, each and everything is going upon the formula. So you can see what is the thing, sec square x of dx is tan x, so tan of z by 2 plus of constant equal to d, it is x. Wow. I think I hope so you can understand. So tan x plus of y divided by 2 equal to x plus of c1. Okay, so this is a generalized equation. Suppose whenever they just give you negative value, just put and you just calculate each and everything. Okay, so let us explain this problem. So you can see y square can be placed here, and 1 plus y square and 1 plus y square will come. So integration of dy by dx 1 plus of y square equal to dx. So integration of this entire thing is tan inverse of y. Okay, equal to x plus of c. So I also understood. Okay, so tan inverse of y equal to x plus of c. Okay, if x equal to 0, it means just a normal thing. If just a constant x equal to 0 means y will come 1. Okay, so while you are just putting, so you can see c equal to pi by 4. So this is a exact equation. Okay, y equal to tan x plus of pi by 4. Okay, so this one I think so just make it square. So dy upon dx, this one okay, make it okay, 1 plus x square plus y square, 1 plus of x square, so 1 plus x square and 1 plus y square. Okay, so root just make it different, okay. Integral of dy upon dx root of 1 plus f. So you can see what is the sine inverse of x. Okay, this one is integral of root 1 plus of x square, this one is this. Okay, just to make the equation correct. I hope so understood. Just the formulas, guys. So this entire, it means entire chapter is only mostly based upon the formulas. See, in this some problems will be quite challenging, but most of the problems will be easy only, especially the exact differential forms and all. It won't be that much tougher at all. So just it means if we just come to common conclusion for just 4 things, the remaining each and everything is easy. So this kind of thing is being easy. Okay, I also understood. So we can just see the next question. Let us just 1 second. உலகம் உன்னை எதிர்க்கும் போது அச்சம் இருந்தாலும் விடாமுயற்சி. See guys, mostly solving the question is so much important in my perspective. So I'll just explain each and everything. Okay, so you can see this one. So dy upon dx e of x, so you can see this is given as minus. Just the matrix dot dy upon dx e of x dot x square e of minus y. Okay, perfect. So make it as dx e of minus y e of x plus x square. So make this as a dy upon e of minus y dx e of x plus x square. So e of y of d of y e of x plus x square of d of x. Okay, so just integrate. Integration of e of x is e of y. Okay, e of x plus x cube divided by 3. This is the equation. So general constant plus the constant. So this one. See guys, while solving the mathematics problem, please, it's like just hum a song while we are just singing. It will just make your mind relax. Okay, so make it okay, sin y plus of y of cos y of dy. Okay, this one x 2 times of x log of x plus of x of dx. Okay, now we just integrate. So separate integration only, not all inbuilt integration. Okay, so you can see this one sin of y, integration of differentiation of causes, differentiation of sinus. Yes, see Supreme Court. Okay, Supreme Court. So differentiation of sinus cos. So this is positive. Differentiation of causes minus of sin. Okay, integration of sinus minus cos. Integration of causes sin. So integration of sinus minus of cos. Okay, minus cos y plus of this one y cos y. So u method. So uv. Okay, u v dash minus of v u dash. So u is y, v dash is differentiation. Okay, okay, integrate. Okay, u v dash is cos or you just sin of y minus of v. Okay, v will be cos of y. Okay, cos of y. U dash is y square divided by 2 equal to. Okay, so this one I think so before in the chapter I just explained to you. So 2x log of x plus of x. Euler's formula. So Euler's means wow, even just see I even just for like Euler's formula. So integration of uv of dx. Mm, wow, wow, wow. Guys, wait. I think so. We are doing some mistakes. See, this is the second time mistake I'm just doing it. Mm, okay, yes, definitely this one will be a right thing only. Okay. உலகம் உன்னை எதிர்க்கும் போது ஒரு சொட்டு மிச்சம் இருந்தாலும் என்னைக்கும் விடாமுயற்சி. This one is not a biggest thing, okay. So it's not a complicated. So I think so. I'll just explain in another video, okay. So because first we need to know about this formula and about the UV formula and UV method. So after having that only we could have a good understanding. Integration of u dv, okay. You can see integration of uv of dx, okay. So here we need to do the integration. So you can see uv dash, like this one we need to come here, okay. So this also divisible of 1. Here the Euler's formula is being used. Euler's. Okay. Okay guys, then I'll just see you in the next video, and until then just take care, have a good day.